So for 9.3, just reviewing the rules. For vertical asymptote, you set the denominator equal to 0. Horizontal asymptote, you look at the degrees and you compare. So what does Bobo Botan Eats DC stand for?
Bigger on bottom 0, bigger on top none.
So bigger on bottom 0, bigger on top none. Exponents are the same, divide coefficients. For x-intercepts, you set the numerator equal to 0, and then y-intercept, you set x equal to 0. So going ahead and looking at this one, what do I already know is different?
There's not an x on top.
There's not an x on top, so then I just use the transformation rules to graph. These are sometimes easier, but since there's just a number on top, then I'm going to use the old rules. So differentiating between first rules and second rules is if an x is not on top, you use the old ones. And so I'm going to go ahead and simplify. I guess this is plus 1, so I can't simplify anything. So for vertical asymptote, what do I do? Set the denominator equal to 0. So x squared. I'm going to change this. I think this is what I had to do on the notes last year. I'm going to go ahead and change this to be a minus 1. Because then you start getting i's, and we don't do that in this chapter. So change this to be minus 1. And then when you have x squared minus 1, what can I simplify that to be? Yeah, so 6 over x plus 1, x minus 1. So then I would have 2 vertical asymptotes, and they would be where? X equals -1 and x equals 1. Horizontal asymptote, is there anything to the side? So I'm just going to say none. Or 0, sorry. I don't know why I said none. Thank you. Also, another way to know that it's 0 is, where is the degree bigger? On bottom. And Bobo, bigger on bottom, 0. So, x-intercepts, I set the numerator equal to 0. There are none. And then y-intercepts, I set x equal to 0. So you get 6 over. So then you get, for y-intercept 0, -6. So I'm going to graph my vertical asymptotes. So -1 and 1. And then my horizontal is going to be at 0.
Why aren't there any x-intercepts?
Because I have a horizontal asymptote at 0. So there's going to be a few examples where most of the time the horizontal asymptote is never touched. So something about vertical asymptotes is they never, ever, ever get touched. Like you don't ever see a graph hitting a vertical asymptote. There are a few examples where sometimes graphs go through a horizontal asymptote. And there's really no rhyme or reason for that other than some graphs have an x-intercept even going through a horizontal asymptote and some do not. So if you get on a quiz or a test and you see a graph going through the horizontal asymptote, do not be alarmed, because horizontal asymptotes are sometimes gone through. There's a very long explanation that is lengthy, and so to say that sometimes horizontal asymptotes are gone through is okay. So don't be alarmed if you see something going through a horizontal asymptote. So if I had an x-intercept, then I would, and I had a horizontal asymptote equals 0, then I would have something like here, and that would be okay.
Oh, okay.
But you don't necessarily always, that is not always the case. So horizontal asymptotes are sometimes like kind of suggestions, like we don't want anything to go through it, but we do. Just not always. So I'm going to plot my point. My y-intercept is at -6. Now, to know how to draw it, my graph will always trace the vertical asymptotes, and it's going to be going away. So that in the middle. I'm tracing the asymptotes, meaning like I'm approaching them, like my end behavior going all the way down is getting towards the asymptotes. And then my rational functions are always in opposite diagonals. So that means I'm going to have one here and here.
So confused. Whoa.
Okay, listen. So it always goes in opposite, like diagonal of.
Like 6 kind of budgets in this one.
Right. So I've got, 1, 2, 3. Oh, that was an eraser. So I'm going to plot my y-intercept. And then I'm going to draw what's ever in between. So if I have 2 vertical asymptotes, then that means I'm going to have some parabola looking thing in the middle somewhere. And then my other 2 functions will be in the opposite ones, the diagonals.
How do you know it goes down?
Because it wouldn't go through. It's not going to go through the horizontal asymptote unless you have an x-intercept there. So it's always going to go away. It's always going to go away from your horizontal asymptote.
So it only like switches up if your asymptote is like on a line.
Yeah. Okay, domain. Now I'm going to have 2 unions for domain. -infinity to -1. So like if I'm reading it from left to right, I stop at -1.
Yep.
-1 to 1.
Oh.
1 to infinity.
What?
This is not that bad. Y'all done this before. Yes. Like the very beginning of the year, you guys did this. All you do is you stop at vertical asymptotes. So here I have 2 breaks because I have 2 of them.
Wait, okay, why do you have -1?
Because if I'm going, I stop, I go, I stop, I go.
Oh, yeah. Oh, wait, I remember this, yeah.
And then range, what would my range be? -infinity, where does it stop? 0. Union, 0, positive infinity.
Every time I do
You can do it, I promise. Okay, number 2. First thing I want to do is try to simplify. Can I do this?
No.
No, because what happens when I do that? Yeah, right. Don't want that to happen. So how can I simplify this?
X plus 3 is
2x squared over x plus 3, x minus 3. Okay, let's look at the rules. So for vertical asymptote, I do what? Set denominator equal to 0. So I've got 2 of them, and they are where? -3, positive 3.
You just put my parentheses around that. Why did I do that? We like started this also when I walked through the door, right?
Mhm.
Basically. Yeah.
They're on bottom 0.
So looking at the degrees, here we've got, I'm just going to look at the first one. They are the same. So y equals what? Good.
Oh wait, I was right. I put 2.
X-intercept, I do what? So x equals x squared equals 0. So x equals 0.
Wait, where'd you go? Okay, we're gonna.
You just divide by, so if I had this,
Oh, and then this
divide by 2. X squared equals 0. And also a little hint, like if it's just a single term and it doesn't have a plus or minus or anything, it's always going to be 0. And then my y-intercept, what do I do? You just plug in x equals 0. So 2 times 0 squared over 0 minus 9. Or you could do 0 plus 3, 0 minus 3. Either one. You get negative 2 ninths.
It wouldn't be.
What? Why did you get negative 2 ninths? Yeah, wouldn't it be 0
that makes
divided by
absolutely no sense.
negative
Whoa.
Oh, 0. Sorry, I can't multiply.
I was like, how is that negative?
0 ninths, which is just 0. Because 2 times 0 is 0.
Good.
Good.
So, going to draw my my asymptotes at negative 3 and positive 3. Horizontal asymptote at 2. And remember, when you are graphing, I'm really only grading the asymptotes and the intercepts. I do want your graph to be going in the right direction, but once you plot those things, I think it is more intuitive. So here I've got this point right here.
It's going to go up.
So what should I do? It's always going to go, if it is not on the horizontal asymptote, it goes away from it. So am I going to draw the going up or down? Down. Because it's going away from it.
Wait, why? Okay.
So it only goes up if it's on.
It only goes, it only goes through it if it's already on the horizontal asymptote. Then I've got them in the diagonals. If you want to use your calculator to graph, you can. But on a test or quiz, no calculator. You just want to see it. The last thing we will learn today is a slant asymptote. So when we talked about bigger on top is none. So when this occurs, you have what we call a slant asymptote. So you don't have a horizontal, but a slant. So no horizontal, but a slant. And slant just means like a diagonal asymptote. And in order to find that, you're going to divide the top by the bottom using synthetic division. We won't do long division.
Oh, no.
I forgot what it is.
I'm so glad you asked because we're about to do it.
Wait, is that like the...
Yeah.
We're gonna bounce back, right? No.
So, okay, first thing I want to do is simplify top and bottom. So, if I were to factor the top, what could that be? Yes, you do.
Minus 1 and lower.
X plus 4, X minus 1.
Good. And we do this to decide if there are any holes or anything, but there aren't. No holes. Okay, second thing, vertical asymptote, set the denominator equal to 0. So where's my vertical asymptote? 2. Horizontal asymptote, I look at the degree, it's bigger on top. It's bigger on top, so I say none for horizontal. But I have a slant, so here is how you solve. You're going to use synthetic division. where where my vertical asymptote is the number that goes in the little box. Then you draw your L, and the numerator is what goes, like the coefficients, remember the numbers in front go along. So I'm reading it from left to right. So it goes 1, 3, -4. If it skips a degree, what do you do? 0. So how to use synthetic division? I bring the first one down, so 1, and then I multiply. 2 times 1 is 2. Then I add down, so I have 5. 2 times 5 is 10. Add down, 6. You will almost always, like 99% of the time, get a remainder, but we ignore it. So just put a big X through it. And we use these two numbers. So every time that you divide, you get 1 degree less. So what kind of equation is this? Just an X plus 5. Because you're doing X squared, you divide, so you're just left with X. So your slant asymptote is always going to be a line, like a linear function, a diagonal. And so if I were to graph these, X plus 5 means I have a y-intercept at 5 and a slope of 1. So my slant asymptote looks like this. My vertical asymptote is at 2. Now I need to solve for my X and Y intercepts. So when I factored, that made my X-intercept journey a little bit easier. So where would my X-intercepts be? -4 and 1, thank you. Nope, 1, 0. And my y-intercept is setting x equal to 0. So somebody plug that in, or I guess everyone. And you get 2. So then to graph, I'm going to connect the dots. These are always kind of fun. And my other graph goes in the opposite diagonal, so it just goes up here. It's just the opposite diagonal. So these functions are never side by side.
Well, will you tell us when it's a slant, or will we have to like determine?
You have to know when it's bigger on top. So when you have a slant asymptote is when you have a degree that's bigger on top. Like when the degree is bigger on top. And then you get a function, we did it, it looked like this. The range, you would have to do it in your calculator because you would want to get the point where it's here to the top and then the point where it's here. And those are usually decimals, and we just don't do that. So we skip range on, I won't even have like a little blank for it. Okay, for this one, it is bigger on top, which means that there's no horizontal asymptote, but you do have a slant. And so for synthetic, the number that goes here is the denominator equal to 0, or your vertical asymptote. And then here the coefficients going along. So all I have is the x squared. I don't have, that's why I put plus 0x plus 0, because you still have to put the zeros there going all the way to just the number. And then you solve and you get 3, 3. You ignore the remainder. And so 3x plus 3. You get an x-intercept at 0 and a y-intercept at 0. So I plot that point at 0, 0, draw away, and then it's going to be in the opposite corner. Okay, so vertical asymptotes have the denominator equal to 0. You get -4. Then you got to use synthetic division because it is a bigger degree on top. And you get 1 and -6. So the equation of that is x minus 6. When you graph that, I extended it to where the vertical and the slant meet because there is a function down at the bottom. Then I graph the x and y intercepts. I got the x-intercepts by factoring and then setting those equal to 0. So 3 and -1. And then the y-intercept is just plugging in 0 for all of your x's to get -3/4. When you graph, connect the dots, and don't forget about this little guy down here. Domain, -infinity to -4, -4 to infinity, and then I don't do range for this. It's a little bit more complicated. So anytime you have bigger on top, I don't ask for the range.